On Friday, we talked about kinetic friction, which is also known as sliding friction or dynamic friction. Kinetic friction is that resistive force, that force of friction that acts on an object that is already moving, that is already sliding. When I push a box across the floor, there's a force of kinetic friction or sliding friction or dynamic friction acting on that box, resisting its motion. I push on it to the right, friction acts to the left to make it harder for me to push. Kinetic friction resists motion when something's already in motion. Static friction, on the other hand, is the force of friction that resists motion of an object that is at rest. I'll explain what I mean by that in just a moment. But it is essentially the type of friction acting on an object that helps prevent an object from beginning to move. How does that act? Again, we'll deal with that in just a moment. There is an equation for static friction that looks an awful lot like the equation for the force of kinetic friction. But there is an important difference. If you remember, just off to the side here, the equation for kinetic friction was mu times the normal force. When we're dealing with static friction, the equation is going to look like this. Where's the important difference? I see subtle differences. FSF versus FKF, mu S versus mu K. There's not very much of a difference there at all, is there? Well, I missed something. Beside FSF, I'm going to put a max. FSF max. When we solve for FKF over here, we get the force of kinetic friction. When I solve for FSF max, we do not get the force of static friction. We get the maximum possible force of static friction. Not the actual value, but the maximum possible value. Here's why. The force of static friction, I sometimes call it the stubborn force. It is the force that changes depending upon how hard we push. The force of static friction will have a maximum possible value, and it will keep getting bigger as I push harder until it reaches its maximum possible value. Let me give you an example of that, okay? Trent's desk right here is at rest right now. Nobody's pushing on it sideways. I'm not pushing on it to the right, so friction doesn't act at all, right? There is zero force of friction on that desk right now. Got it? Let's say, using this equation up here, I was to calculate the maximum possible force of friction on Trent's desk to be 50 newtons. That varies, right? It depends upon the coefficient of friction, it depends upon the normal force. But let's say in this situation, the maximum possible force of friction on Trent's desk was 50 newtons. Got it? Okay, if nobody's pushing on Trent's desk, the force of static friction is zero. If I push on Trent's desk with a force of 5 newtons and it doesn't move, right now I'm pushing on it with 5 newtons, doesn't move, then it's in a state of equilibrium. Force is balanced. Okay, how big is static friction now? If I'm pushing on it with 5 newtons to the right, static friction must be pushing to the left with 5 newtons. Not 50, but 5. I push with 5, it pushes with 5. Now I'm going to push with 20. Does it move? Nope. How hard is friction pushing? I push 20 to the right, friction pushes 20 to the left. It's in a state of equilibrium. The forces must balance, right? I push with a force of 45 to the right. How hard is friction going to push? 45 to the left, because it can push as hard as 50, right? It pushes 45 to the left. Does it move? It's in a state of equilibrium, right? I push 45, it pushes 45 opposite way. Equilibrium, it's going to stay at rest, right? I push with 51. I push with 51. The maximum possible force of static friction is 50. Ooh, I beat it. I finally won. It's stubborn, right? As I pushed harder, what did it do? It pushed harder. But now it's given up. I've won. I beat it because I pushed harder than the maximum possible value. If I push with 51, guess what happens? It moves. What's the force of static friction now? Oh, trick question. What's the force of static friction now? 0. Why is the force of static friction 0? Because it's moving. Therefore, we don't have static friction. We have kinetic friction. We could find the value of kinetic friction by using this equation now. Make sense? It's a static friction problem until it moves, and then once it moves, it's a kinetic friction problem. Kinetic friction, I'd rather deal with a kinetic friction problem because when I calculate its value, that's its value, right? I push with a force of 51 newtons. Let's say kinetic friction was 40 newtons. I push with 51 newtons. What's kinetic friction? 40. If I push with 100 newtons, what's kinetic friction? 40. I push with 1,000 newtons. What's kinetic friction? 40. Static friction is the stubborn force. It's the one that pushes as hard as I push. It's like taunting me, right? It's the taunting force. Its maximum possible value is 50. I push with 5, it pushes back with 5. I push with 10, it pushes with 10. I push with 15, it pushes with 15. I push with 35, it pushes with 35. It just does what I do until I beat its maximum possible value. And then it gives up, kinetic friction takes over. And I'm okay with that because kinetic friction is the same no matter how hard I push or no matter how fast it's moving. All right, question?
Yeah. So can you just like
Well, yeah, that was just the example in this particular example, right? We'd have to calculate the maximum possible value given the coefficient of static friction, which, by the way, will be higher than the coefficient of kinetic friction. You ever, let's say you want to rearrange the stuff in your bedroom, and you got to push your bed over here and push your dresser over here. You ever done that? Something heavy like a dresser. You don't want to take the drawers out of the dresser or take the clothes out of the dresser because that would be a pain, right? So you just leave all the drawers in there, but it's heavy, right? With all the clothes in there, the dresser is heavy. When you go to push it, it's like, it doesn't want to go. It doesn't want to go. But once it starts moving, it's easier. Have you ever noticed something like that? You push something and it's hard to get it moving, but once you get it moving, it's like, okay, it can't stop. Otherwise, it becomes harder to push again. Do you know why that is? Because kinetic friction, listen carefully to what I'm about to say because there can be a misunderstanding here. Kinetic friction is not necessarily less than static friction, but kinetic friction is always less than the maximum value of static friction. So in this situation where the maximum value is 50 newtons, I push with 30, doesn't move. 40, doesn't move. 47, doesn't move. 48, doesn't move. 49, doesn't move. 50, moves. Got it? I had to push with 50 newtons to get it moving. But because kinetic friction is less than the maximum static friction, kinetic friction would be more like 40. When I pushed with 30 newtons, static friction was less than kinetic. But the maximum static, the force that was required to get it moving, was more than the kinetic friction. Does that make sense? And along with that, the coefficient of static friction is going to be bigger as well. So we say static friction behaves differently than kinetic friction in that it acts only as strong as it needs to. It's the stubborn force. If the maximum value is 50, I push with 30, it just pushes back with 30 because that's all it needs to. I push with 40, it just pushes back with 40 because that's all it needs to do. I push with 49, it pushes back with 49 because that's all it needs to. The value of that static friction will not be the equation. The value of static friction will not come from the equation. The value of static friction will be the same as the applied force. However hard I push, that's its value, unless I push harder than the maximum value. Then it begins to move. And when it begins to move, it ain't static anymore. Now we got kinetic friction, which I can calculate using the equation that I learned on Friday. Now, this paragraph comes down to what I said a few minutes ago as well. Static friction is not always greater than kinetic friction, but the maximum value of static friction is greater than kinetic friction. So if the max value of static was 50, kinetic would be more like 40. Just because the max value is 50, though, that doesn't mean that's what static friction is. If the max value is 50, let's say in a particular situation, the maximum value of static friction is 50. The force of kinetic friction in that situation is 40. The force of static friction could be 10, could be 20, could be 30. Those are less than kinetic friction. We're not saying static friction is bigger than kinetic friction. We're saying the maximum static friction is bigger than kinetic friction. That's why it's harder to get an object moving than it is to keep an object moving. Because in this situation, right, where FSF max is 50 and FKF is 40, I would need to push with a force bigger than 50 to overcome static friction, to get it moving. I'd have to push with 51 to get it moving. How hard would I have to push to keep it moving? 40. I just have to balance kinetic friction to keep it moving. Okay, let's have a look at example number 6. A couple examples I want to do, but this is the biggest one for sure. This is a 20 kilogram box at rest on the floor is being pushed to the right. There's a coefficient of static friction between the floor and the box of 0.6 and kinetic friction between the floor and the box of 0.4. Static friction coefficient bigger than kinetic friction, right? Determine the force of friction between the box and the floor if it's pushed with the force of whatever. So I push with 50 newtons, I push with 100, 150, 200, whatever. What kind of friction are we solving for here, static or kinetic? It doesn't say, does it? It just says, what's the force of friction? How do we know whether it's static or kinetic? If it moves, it's kinetic. If it doesn't move, it's static. Does it move if I push with 50 newtons? I don't know. I don't know. Any ideas? Sorry? Well, it starts at rest, right? And I'm pushing it. So the only question is, when I push it, does it cause it to move or not? If it does cause it to move, we've got kinetic friction here. If it doesn't cause it to move, we've got static friction. Here's what I want to do first. Off to the side, I want to calculate the maximum possible force of static friction. That's not the actual value of static friction. That's the maximum possible value. We're going to use for that the coefficient of static friction is 0.60 times the normal force, which is 20 times 9.81. I have not answered anything yet. 0.6 times 20 times 9.81 gives me 1. Here, let's switch that back to normal mode from scientific. Gives me 117.72. This is not the answer to any of these questions. This is not the force of friction that acts at all in any of these. This is the maximum possible force. Got it? Okay. I push with 50. Does it move? No, why not? I got to push with at least 117.72 to get it moving, right? I have to overcome the maximum force of static friction. Remember, static friction is stubborn. It does what I do until I push harder than the maximum value. So if I only push with a measly little 50 newtons, it pushes back with a measly little 50 newtons. The force of friction here is static friction, and it is 50 newtons. It's not FSF max, it's just that is the force of friction. I push with 50, it pushes with 50, the object is in a state of equilibrium and it doesn't move. If I push with 100, does it move? No. I have to push with at least 117.72. If it doesn't move, what's the force of static friction? What is it? 100. It's however hard I push, right? It's the stubborn force. It pushes as hard as I push. It's 100 it is. There's no real sig figs to worry about there, right? Because I only just used one number, right? 50, 100. I push with 150. Does it move? I won. I beat static friction now, right? What's the force of static friction now? 0. What kind of friction do we have? Kinetic friction because it's moving. Let's calculate kinetic friction over here. The force of kinetic friction is mu k times Fn. Mu k is 0.4 times Fn. $78.48. Remember we said the kinetic friction is always less than the maximum static friction? It is, right? 78 compared to 117. It's not always less than static friction. Static friction here was 50. Kinetic friction is 78. It's less than the maximum static friction. Okay, I push with 150. Does it move? Yes. What kind of friction do I have? Kinetic. What's the value of kinetic friction? We'd say the value of kinetic friction is 78 newtons. If I push with 200, does it move? Yes. Okay, John, if it moves, what's the force of kinetic friction? What? 78. Because kinetic friction isn't stubborn, is it? Like it's 78, it's 78, as long as an object is moving. What if I pushed with a value? What if I pushed with a force of 17,129.2 newtons? What would the force of kinetic friction be? 78 newtons. Got it? Kinetic friction is not stubborn. It's this guy, it's static friction that keeps pushing harder as I push harder. Once it starts moving, kinetic friction is what it is. Yep. For B, no, well, you do have to do significant figures for all of them. Let's look at C and D here first, though. Okay, that's the easier one. C and D with calculated kinetic friction to be 78.48, and we used 2 digits here, right? So the final answer should be 2 digits, correct? But in A and B, we do have to do significant figures for both of those as well, but it should be easier for us because when we're saying 50 newtons, we're not using we're not using any of the 0.6, the 20, the 9.81. The only thing we're using for this answer of 50 newtons is this. So if that's 2, then this has got to be 2. If this is 3, then this has got to be 3. Does that make sense? Just because 0.60 is 2 digits doesn't mean we're going to make this 2 digits because in our answer, we didn't really use that 2 digits. That make sense? Good. Okay, I'm going to put one up on the board here, not from your worksheet. I just want to throw one up on the board and see what you guys can do with this yourselves for a moment here, okay? Let's say we've got a 50 kilogram box. 50 kilogram box or 50 kilogram sum. The coefficient of static friction is 0.90. Give me a value of the coefficient of kinetic friction. I mean, it could be anything, right? But give me a reasonable value for it. No, 1.2 is not a reasonable answer for it, or value for it. What do we know that it has to be? It has to be less. It's 0.90, right? So it could be anything, right? Anything less than 0.90. We'll make it 0.75. Okay? We want to find the force of friction. We want to find the force of friction in each of these cases. A, when the applied force, that's the force that I'm pushing with, the applied force is 200 newtons. What about when my applied force is 400 newtons? What about when my applied force is 600 newtons? And what about when my applied force is 648,237,919.7146 newtons? What's my force of friction then? So I want you in all four of these to identify what type of friction you have, and I want you to identify the value of friction that you have, using the last example that we did as a guide. Let's take a look here now, guys. So we got a 50 kilogram box. We have a coefficient of static friction of 0.90, kinetic friction of 0.75, which we expect to be a little bit smaller, right? Sometimes it's quite a bit smaller, sometimes just a little bit smaller. But coefficient of kinetic friction is nearly always smaller than static friction. That's why it's harder to get an object moving than it is to keep it moving. What's the force of friction, static or kinetic, if we apply a force of 200 newtons? Well, we got to ask ourselves, does it move first? Does this move? We don't know. So we have to find the maximum force of static friction off to the right. Let's do that. FSF max is equal to mu s times the normal force. This is not the force of static friction. This is the maximum possible force of static friction. 0.90 times 50 times 9.81. What does that work out to be when we do that? 441.45. So that's not the answer to any of these questions. This is just the maximum possible force of static friction. Remember, static friction is that stubborn force. It pushes as hard as it needs to push. If I push with a certain force, it pushes with that same force, unless I push harder than the maximum force. So if I push with 200, what does it push with? 200. Static friction then will be 200 newtons. Because if I don't exceed the maximum possible value, it's going to do whatever it needs to do to keep it from moving. It's an equilibrium, right? I push a 200, it pushes a 200, the net force is 0, it stays at rest. Okay, I push a 400, does it move? No, I didn't exceed the maximum possible value. So I'm going to say the static friction force here is 400 newtons. It's the stubborn force again. It needed to push with 400, it pushed with 400. Force that I push with balances the force that it pushes with. It's in equilibrium, doesn't move, stays at rest, right? I push to 600, does it move? Yes, I win. I exceed the maximum force of static friction. So it's now kinetic friction. I have to find out what that kinetic friction force is. So let's off to the side calculate that. It's equal to mu k times Fn. We would expect that to be smaller than 441, but not necessarily smaller than 400 or 200. Just smaller than the maximum possible value of static friction. Mu k is 0.75 times 50 times 9.81. What does that one work out to be? Sorry, what is it? 367.875 newtons. Thank you. I'm going to leave the unrounded number here because it's not a final answer yet. I push with 600 newtons. It moves. What's the force of kinetic friction? Because it moves. What is it? 367? Except where do I run around that to? 2 digits. Now I can't round 367 to 2 digits without putting it in scientific notation, right? So I'm going to round that to 3.7, right? 3.7. How many places did I move the decimal? 1, 2. 3.7 times 10 to the 2 newtons. If I push with 648,237,919.7146 newtons, does it move? Yep. Okay. So what's the force of kinetic friction? 3.7 times 10 to the 2 newtons. Good. Okay, rather than give you a question off the worksheet, because I want to do a couple more examples before I do that, I'm just going to change a couple numbers here and have you do this question again for homework, okay? Just one question for homework with a couple numbers changed around. These ones are all the same, right? Except that they have different numbers. You go through the same method for all of them. So we'll have you try one of those. Let's make it a 150 kilogram box. Let's make the coefficient of static friction 0.80 this time. Let's make the coefficient of kinetic friction, let's leave that as 0.75. This time, let's apply a force. Let's apply a force of 700 newtons. Let's apply a force of 1,500 newtons. Let's apply a force of 5,000 newtons. And let's apply a force of, what do you want to go, Marcus? What do you want to do?
8 billion.
8 billion? Okay, hold on. 8 billion, 952 million, 679,000, 289.3256 newtons. So what's the force of friction, kinetic or static, in each of these four cases? That's your only homework question for tonight.